Um, there's a few topics I wanted to revisit. The main topic I want to revisit today is conditional probability. Um, and you guys will see why it relates to two things I'm going to show you how to train. One of them is how to use Shield effectively, and the other one is how to actually charge a headbutt. Someone asked me before how to charge a headbutt, and so I'm going to be walking you guys through both of those. Now, before, um, it wasn't anyone's fault, like from the community, why charging headbutt wouldn't work. It was actually our fault. We didn't account for something in the code, and I'll explain to you exactly what happened and why it kind of went under the radar. But because I remember when someone asked me how to do this, I was like, okay, let me try it, and it wouldn't work. And I'm like, what the heck? Why isn't it working? And it was actually something in our code, which I'll explain to you guys. It was this weird, sneaky bug. But those are the two things I want to cover. Um, Before I get into those, I want to explain one change that we made, and I'm going to explain why we made it. So, for anyone who has played our game in the past and who is not currently in exclusive access, you will know that in order to execute a roll, it's shield plus one of the sides, right? So it's shield plus the right or shield plus the left, right? Um, Now that made executing shield really tricky because usually when people train their AI, they always train their AI to move in a certain direction, most of the time to follow the opponent and then attack the opponent, right? But if you wanted to sprinkle in like a shield, right? Like for example, most of the time you wanted it to move right and attack the opponent, but sometimes you wanted to press shield, it wouldn't work and instead it would execute a roll, right? The reason is because you're still holding the right button. Um, and obviously, this is not desirable. People wanted to be able to do shield even when they were holding the right button. And so what we did is we moved roll into down plus right. So you see here, my agent is holding down and right. So it's diagonal. Also down and left rolls to the other side. So instead of right plus shield, you just down right in order to execute the roll now. And I'm going to actually show you guys basically how the neural network is set up so you kind of um, have a bit more appreciation for why that this is the case. So as you guys know, neural networks take in like a bunch of inputs, right? Let's call it X. And then it passes through a bunch of like hidden layers. I won't draw the nodes, but basically they're connected. They pass through the hidden layers and then they go into outputs, right? And for our neural network, what we do is we split up the outputs into what we call two heads, okay? And I'm going to color code them differently. So one head, call it blue. This will be the direction. The other head, red. Um, Call this like the combat actions, right? With like defensive and attacking. So this is everything to do with combat. This is everything to do with direction. And intuitively, if you look at like controller, right? Um, you have sort of like your directions over here. Your other actions like you have with the various buttons, and then there's the triggers as well. And so if we color code them, we know that this corresponds to this, and we know that all of these corresponds to this. And so what you can think about our neural network doing is each head controls like maybe like a hand, right? So this hand controls directions and this hand controls all the combat actions. Now, why did we set it up this way? Um, I'll show you a simple example of why we set it up this way. So as you guys know, so we'll denote attack with A. So A plus up equals uppercut, right? S- Um, ugh. Actually, I won't even denote it with the actual name because the names are currently in flux. So A plus up equals, we'll call it like um move 1, so M1. And then A plus right or left, call that move 2. A plus down equals move 3. A without any direction is move 4, right? And then we can also do this with the other ones, right? We have the special plus up, that's move 5. Special plus side equals move 6. Special, just special equals move 7, right? And you can see that every possible combination we have is a new move, right? Now, instead of making the actions every single possible combination, what we do now is we separate the direction from action. So now A and S are two actions we can take, right? And then if you look at it on the other side, we can do up, side, right, left, right, and down. So this is 6 actions in total, and it's already less than this, right? And then if you imagine if we wanted to do special plus down, that's another action. Special, if we wanted to combine special plus diagonal, that's another action. So instead of making um, basically like exponentially more actions by having each action be the combination of everything, what we do is we separate them, right? And now we can reduce what we call the action space drastically by taking each of these independently and then combining them to get what the move is. Okay, so that was the inspiration for this, and the reason why we do that also is because if in the future we wanted to add in a new move, right? For example, let's say right now, let me remove this. Right. So let's say right now, if we did this approach, right, where each action, right, like each action in the output is like a different node over here, right? So it looks something like that. And let's say we wanted to add in a new thing. Maybe it's S plus diagonal, and that's a new action over here. What we would need to do is we need to add in a new node. And this actually disrupts the entire neural network because you have to remember the neural networks, um, they work off of weight matrices. So, like, there's all these connections. And so, when we introduce a new one, we have to introduce a new connection, which means we have to change the weight matrix, um, and ultimately, that disrupts the entire neural network because now this also changes the probabilities of everything that came before it. It changes all these probabilities once we introduce a new weight in here, right? And so now, if we ever want to do an upgrade to the game to say, okay, there's this new action we're introducing, literally it'll affect everyone's neural network because once we introduce that new weight, it's going to change all their probabilities, and everyone's going to be like, what the heck? Why'd you do that? So, in order to not run into this problem, we did this approach where we predefined all the possible buttons we'll be able to press, right? And now, if we want to introduce a new move, we don't do it at the neural network level. We do it at the level after the neural network once we combine these. Okay? Um, I hope that makes sense as to why we chose this approach. Now, because we chose this approach, it does lead to certain problems. And that was exactly the shield problem that happened, right? When we decouple direction plus combat, right? We have to like we have to count on the fact that the neural network is going to be able to learn the joint probability well, right? Versus um let's say like T was the trigger, right? So let's say this is like a new action, call it like M10. T is the trigger to do shield, right? If we just had every single possible action as a separate node here, and we didn't divide direction and combat, then it would be easy because we can teach it just to do this. But now that we basically separate them, we have to hope, or we have to teach our AI not to press any direction in order to execute the shield, right? And this works kind of well if you teach your AI to stand still. But most of us are teaching our AI to chase the opponent, right? Like this is the if this is the stage, right? And this is you. Most of us are teaching our AI to go towards the opponent, right? And then execute some sort of attack. And so if you're holding the right button and then you press shield, it's just going to roll. It's just going to go underneath the opponent, which is not a bad thing, but some people wanted to do shield. And you'll see with an update we're going to release soon, shield is going to become very important part of the meta. I won't say what it is, but it's very exciting. Um, so we do still want people to execute shield. And I'm going to elaborate on this a bit more before I pause for a question as to why exactly this is a problem. Um, and it comes down to how we select actions for each of the heads differently. Okay. Now, those who play this game will know like this looks something like the probability of like taking a direction. Let's say it looks something like this. So there's a very high probability of moving towards the right, right? And let's just say attack has like a probability of 70%. And then shield, let's just say there's only two actions here, has a probability of 30%. Well, most of you know that for this head over here, the combat head, um, we select the actions probabilistically, right? So we use these probabilities to sample. So 70% of the time when we sample, it'll be attack. 30% of the time when we sample, it'll be shield, right? And this is fine, right? This is exactly what we want. But for the directions, right? For these directions over here, we sample or we take actions deterministically, which means let's say the right had a probability of like 55%, right? And let's say idle, which is like the null action, had a probability of like 20%. And remember, to execute shield, we need to press the shield button and we need the direction to be idle, right? In this case, you would never do shield because what we do for direction is we select the direction with the highest probability. And now, so you're always going to do right in this situation. Um, and now you might be wondering, why do we do this? Like, this makes no sense. If we select the combat actions probabilistically, why do we select the directions deterministically? Um, and ultimately, that comes down to trying to make the game feel smoother. So I'll give you an example. Remember, in our game, we run at 60 FPS, so frames per second. So there's 60 basically um, 60 instances in which the AI can take an action per second. Yeah, and now if you think about it, like 1 second passes like nothing. It's like 1 second, right? But 60 actions are being taken. So let's look at this case where there's a 55% probability of moving towards the right. And let's say this is the ground. We start off right here, right? And we say we want to move to the right. And if you hold the right for 1 second, maybe you move to like right here, right? But um, because there's only a 55% probability, maybe like after frame like 3, it chooses another action. So like let's say you're right here, it chooses another action. And now you're and remember, 3 frames is nothing, right? It's a fraction of a second. And imagine every few fractions of a second, your AI is going right and then it stops, and it goes right, then it stops, and it goes right, then it stops. It's very choppy, right? And that's the experience we had is when we were designing this and we were selecting directions probabilistically, it looked very, very choppy. It was like go stop, go stop, go stop, right? And ultimately, it just didn't look good. So we decided to choose actions deterministically. But ultimately, that has this negative effect when you need to execute a move that requires the direction to be neutral. So, um, the thing that we did in the interim was we changed shield to work with all directions now, and then roll is just diagonal down. Now, is this a perfect solution for the long term? No, because there are other moves where we would want to basically use the neutral, or maybe, for example, if you're imagine you're in a scenario where you're right here and your opponent's right here, sometimes you just do like side attack, and you want to mix it in with maybe like a low sweep. So 1, 2, right? The state is the same, but you want to like mix it up like this, and or maybe you want to do an uppercut, right, to maintain this unpredictable nature. In this case, we do want to sample the directions probabilistically. Um, the good news is we're working on this, and we're trying to come up with a way to execute directions probabilistically that still looks smooth and it won't run into this hiccup over here where we keep stopping. But I just wanted to explain kind of why we made the decisions we did and why everything's set up the way it is. Um, yeah, I'm going to pause for a second to see if anyone has any questions because I unloaded a lot onto you guys, but I did want to explain um, this change that we made with the shield and roll and explain kind of why and everything is set up the way it is and how it led up to this point. I'm going to pause for a second. Malcolm, let me know if we have any questions.
Nope, I don't see question so far. Reggie's do make the comment. This is an awesome change. So good feedback.
Oh, awesome. I appreciate it. I appreciate it. Okay, cool. So with that said, let's get into some training. Oh, and then yeah, I'll train shield right now. I want to revisit the concept of conditional probability, and then I'm going to train headbutt. I forgot who asked me, but someone asked me how to do headbutt, so I want to make sure to show them as well. Okay, so let's um, let's hop back in here. I want to. I don't want to train that guy. I want to train my girl over here. Okay, so first thing I want to train is how to do shield. And I think I might have mentioned this before, but to execute a shield, you need to hold it, right? And so we need to make sure the conditional probability of pressing shield once we are in the shield state is high. Okay, so let me just show you a quick example of that. I'll just move this guy down here. And so what I'm going to do is I'm just going to do a bunch of random things over here. I'm just going to attack the opponent, and then I'm going to sprinkle in the shield. So I'm going to do shield, and I'm going to hold it. Now, it's important that you hold it so that your AI kind of knows that once it's in shield, to keep doing shield. Um, Actually, I shouldn't have. I'm going to restart the session. I shouldn't have held the headbutt because I want to show you guys that later. So I'll just start off again. Um, the great thing about training is that you can restart whenever you mess up. Okay, and I'm going to hold shield. Okay. Um, I do want to show you guys something after about shield. Oh, I just held it again, but it's all right. I'll hold shield again. I'm just gonna do it a few times, and the reason is because, as you guys know, you need to show some repetition to your character, and then I'll just do it once more. I'm just gonna hold shield. Now I'm gonna stop recording data for a second just to show you guys. I don't know if everyone's aware of this, but if you hold shield too long, the shield can actually break, and then you're in a state of stun, so you can't do anything now, right? And this lasts for a decent amount. So while it's important to teach your AI to hold shield, you don't want it to hold it for the entire amount of time. Okay. So I'll end the training session over here. Um, and in this case, I'm, of course, when you do an actual training session, you would use probably more features that are targeted at specific things. I'm only going to press your action over here because I only care about what I'm currently doing. Okay. I'm going to dial epochs up a bit and let's train. So you see that shield is going up, but like a bunch of probabilities are going up because we did each of these, right? We did shield, attack, and special. And what I'm going to do now is I'm going to press shield, and you see that the probability of holding shield goes up like crazy. And this is exactly what we showed it. We showed it that when we are pressing shield, we want to increase the probability. right? Because you'll notice when I was in the shield state, I didn't do any of the other actions. All I did was continue to hold shield. And this is what it is needed in order to basically hold it. Now, remember how I said that, for example, when you try to move, it can get really choppy, right? Because there is like a certain probability of selecting something other than right in this example. It's the same thing with shield, right? If you let go of shield, it's going to exit out of it, and you're going to get like a really choppy thing where your AI is like holding shield, then dropping it, holding, then dropping. And what you want is you want it to properly hold shield, right? So that's why we really care about increasing the probability of shield when it's holding it, right? Um, so when we press it, I guess in this state, I guess we mostly did it in this state. I'm sure there's some other states where we did it as well. Um, I guess did I do it when the AI was far? Oh, wait a second. I know why that is. Okay, that's a bug in the AI inspector that if I'm not intersecting with the thing when I come to it, it like it doesn't change the probabilities properly. So if I go here, yeah, so this is correct. So it did actually learn to increase the probability of shield in all these states, which is great. Um, Ideally though, when I train my AI to do shield, when it's holding shield, I like getting this to like 90% probability. That usually has it so that it holds the shield like for like a solid amount of time where it's actually effective. Um, yeah, I might pause for a second to see if anybody has any questions here. Oh, and by the way, this feature that I pressed, your action, this is just telling your AI what it's currently doing, right? So that's why, for example, it's able to learn that when I'm holding shield, increase the probability of shield, right? Because I'm telling it that the current action I'm taking is to press shield. And if you wanted to train, for example, on if your opponent is doing shield and you want to grab it, what you would do is you want to train on your opponent's action. Okay? So this contextualizes it for your AI. I'm going to pause for a second to see if anybody has any questions here.
Nope. We haven't seen one. I think you did a really good job in explaining this
Oh,
concept.
you're flattering me, man.
Yeah. Yeah. But one
um,
question from my side though, like
yeah.
the entering into Shield has been explained it, and then the extension of Shield has been explained it. Now you mentioned there is a penalty for using the shield completely, which stuns you.
Yes.
Is are we going to have a timer system for the shield? How does your AI learn that?
That's an excellent question. Yes. So currently there isn't the feature for the as you may have noticed, there isn't a feature in here for the timer of the shield. We are going to add it 100%. Um, Partly it's probably a misstep on our part because we didn't expect shield to be such a big part of the meta, and as I mentioned before, we are making changes to make it a bigger part of the meta. Um, so yeah, we will certainly put that. So we're going to put basically the shield health in there. So that's how big the shield is. Um, and we have a couple other things that we're going to put in, but I'll let that be a surprise for you guys.
Awesome, awesome. That's good stuff. All right. I think
Okay,
we can move on.
should we
Yes.
keep going?
Yeah.
Okay, cool. Okay, cool. So next thing I want to show you guys is the headbutt. It's going to be a very, very similar concept, but I just wanted to show you guys. Another thing to note, um, some people previously they would um, exit the AI inspector before pressing quick save. I want you guys to note that this does not save your model, and so you basically all your progress is lost. You actually have to quick save if you want to save it. In this case, I don't care. So I'll just go directly to training. And if you want to stop seeing this message, just click this over here. Okay. Um, let's hop into here. Okay, so we can do something similar where we're just going to be taking a bunch of random actions. Um, and then I'm going to hold headbutt and then I'm going to release it. And I'm going to do it a few times on each side. Um, and then I will explain why the headbutt is set up the way it is, and why that was causing problems before. I can't recover. I think that that's probably sufficient over here. I'll end training. I did headbutt a few times. I mixed in some other stuff. And I'm going to again press your action. I'll also press direction because I care that we're facing the opponent, and angle to the opponent to, yeah, to make sure that we're facing the correct direction. And then let's train the model and see what happens. All right, cool. So it worked. Okay. So you see that we did a lot of attacks and special in this training session. So accordingly, it increased the probability of attack and special. And when I click special, so when I'm holding special, which is the headbutt, right, it increased the probability of doing the headbutt, right? And then if I let go of it, now the probability of attack is a lot higher, right? So it learned that once I'm doing headbutt to increase the probability. And I'm sure if we switch to the other side, um, same thing over here, right? Once I press to the right and special, which is the headbutt, it increased the probability of headbutt by a lot, right? In this case, it looked like it has a bit more of a bias to be able to do it correctly on the left side than the right side, but I'm sure that just comes down to how much I trained it on each and in which situations I showed it. But you can certainly see here, there's a higher probability of attacking, and then once you hold right and special, which is the headbutt, basically the probability swap, and now the majority of the probability is on holding the headbutt, which is exactly what we want. So now people will finally be able to do more powerful headbutts and hopefully not spam them. Um, but yeah, very excited about this. Now, I want to explain why it didn't work before. Um, and it ultimately came down to how we set up the headbutt and how we were actually collecting data for actions. So the way the headbutt is set up is we actually have a timer on the button presses, right? So if I just hop into training, so if I if I just hold headbutt, it's executed, and now I'm still holding the exact same buttons, right? But it's not doing headbutt anymore, right? I was still holding it. Similarly, I'll do the other side. After it releases, I'm still holding it, but it's not doing headbutt. So what happens is I actually have a timer on certain buttons. The special button is one of them, where if you continue to hold it, it drops it after a while, right? So I think it's about after 7 frames or so, it acts as if you're no longer executing that action. Now, of course, it continues to charge it because of how we set up the state transitions, where once it's in the charging state, it's going to keep the charging state until you actually let go of the button, right? But while you keep holding the button, it's not registered as a valid new action, right? So once it's completed, it's not registered as a new button press for special. And what happened is when we were collecting data, we were only collecting new button presses for special, which obviously messed everything up because you can imagine, um, boom, like it already stopped. Like literally when it started charging, it stopped registering special as like a valid action. And so you probably only collected 1 or 2 frames of special. Um, before it kind of stopped being collected, which obviously meant that you weren't actually training to charge the to charge the headbutt because that conditional probability and the data was never there, right? As soon as you started pressing it, now the action stopped getting recorded, and so there is no conditional probability to learn. Long story short, we had to we had to reconfigure how we collect data and how we register the AI knowing that we're holding the headbutt, and so now it's able to successfully do it as you saw with the previous training session that I showed. Um, there is still some more work to generalize this because right now we have it hard coded to just work with the headbutt in this case. But if we ever want to introduce more charging attacks, we need to generalize this in the code a bit more. So we're going to take a little more time before pushing this to production. Um, and yeah, that's kind of the major topics I wanted to cover with you guys. Let me know if anyone has any questions.
Yes, Reggie's have a question regarding the AI inspector. How do you know
Mhm.
that you're holding the headbutt and not spamming it?
Okay. That is a good question. So, okay, get out. Let's get out the pen and paper. 1 second. So, um, let's just say, okay, so the way the game works, right? Let's just say you have n number of frames, right? So this is like frame 0. I don't know what this frame is, but like it keeps going, right? There's 1, 2, 3, 4. The way the game works is that each frame we sample what button we're pressing, right? So if this is our controller, right, we're going to sample it here. The next frame we're sampling it again. Frame after that we're sampling it again, right? So the way any kind of game engine works is that we're going to see what button we're pressing at each frame, right? So if in this frame we're pressing button B, this frame we're pressing button B, this frame we're pressing button B, the game interprets it as you holding the button B, right? And so long as you hold it, and then maybe this frame you press button A instead of B. So you are holding it for for 5 frames over here, right? And because like if it runs at 60 frames per second, it's literally impossible to click it to do BA. It's literally it's humanly impossible, right? So if we notice that each frame you continue to use that input, i.e. it's continued to be pressed down, we interpret that as you holding it. So similarly, we have a neural network, right? And a neural network like takes all these actions, right? It looks something like this. It's taking all these actions, and each frame we're also sampling from the neural network, right? And so what happens if the neural network at each frame is also pressing a button, right? So it chooses to press a button, then we interpret that as the neural network choosing to hold that button. So what does that mean? So let's say that we have a probability distribution. Let's use this one over here. And let's say frame 1, we sample attack, right? Frame 2, we sample attack again. Frame 3, we sample attack again. Frame 4, we sample shield. So what happens is the game engine interprets the AI as holding the attack button, right? So what does that mean if we look at the AI inspector? It means the higher the probability of an action, the more likely it is to hold that button, right? Or be interpreted as holding that button because it's more likely to sequentially sample that frame after frame, right? So if we had attack as 100%, then we can be certain that the AI is literally just going to hold the attack button because every single frame it's going to sample it, right? But if we have attack as, for example, let's just say attack is 50% probability instead, right? We can actually calculate the probability of it holding, right? So we have, let's just say we have frame 1, right? There's a 50% probability of sampling. Frame 2, there's a 50% probability of sampling, which means that to press attack frame 1 and frame 2 together, there's a 25% probability, right? The joint probability, right? And then frame 3, we have another 50% probability, right? Which means now the probability of basically sampling attack 3 times in a row is 12.5% probability. and so on and so forth. And so, in order to maximize the probability of holding an action, you want the probability to tend towards 100%, right? And you can imagine, like, you can do the same math, right? If the probability of sampling attack was 90%, right, then the probability of sampling attack for 2 frames in a row, right, is 81%, right, and so on and so forth. So that's how you can interpret, basically, or at least translate the probabilities that you see in the inspector into your odds of holding this button in game. I hope that makes sense.
Mhm, mhm. So,
We do have some additional things in game that I don't wanna get into, um like, um like, we have a drop counters for, like, the shield, so that if even if you let go, we have a counter to make sure you let go for N number of frames before we actually transition out of the shield, but, um, that's probably a discussion for another time on specific mechanics.
mhm. So in the AI inspector, so my understanding is that if you have the attack and special like a 50-50, most likely it's going to be more spammy, like the headbutt
Yes,
spamming we see in beta 2.0 for, per se. But if we see like a 90 to 100% on the special, it would be like most likely a charge headbutt.
exactly, exactly. Yep.
Got it, got it. Yep, seems clear for Reggie as well. And also, just side question for me. Um,
Yes.
in the interpolation, we mentioned that like your AI can interpolate if you execute the same action but in two different position, right? So it
Mhm,
knows to act similarly between those
mhm,
duration like position. But what about headbutt? Like say if I one point I charge it at the first frame, and then the
mhm.
other time I learn it to charge it to all the way. Does it interpolate the like to release the habit somewhere in between, or does it is it more gonna be discrete?
Um, it is going to that's a that's a great question. Um it's going to favor charging the headbutt. Um, and the reason for that is because you have to think of the conditional probabilities. And like I'm assuming you only mean one of each, right?
Yes.
Okay. So I'll give you an example. So in the first case where you just press it once, right? What's going to happen is, and I'm assuming that you intentionally put your action as the feature you're training on, right? Because you care about the current action you're taking,
Mhm.
right? So if that's the case, then in the first case where you just clicked headbutt, what would happen is it's only going to register one data point, right, for that conditional probability of you're in the headbutt state and then you let go, right? Because you just did like a quick press. But if you hold headbutt and you're charging it, what's happening is it's actually sampling every like few frames, right, to know that you're charging it, right? So in the state that you're in headbutt, let's just say it samples it 20 times, like you fully charge, like it samples it 20 times that when I'm in the headbutt state, I continue to do headbutt. And now you look at the balance of the data. When you charge it, you have 20 examples showing it that when I'm charging it or when I'm in the headbutt state, I continue to do headbutt versus one sample of saying when I'm in the headbutt state, I no longer do headbutt. Now that you see a huge skew, right, in the data, right? There's a huge imbalance towards when I'm in the headbutt state, continue to do headbutt. And so you would expect that the probabilities to skew in that direction. Does that make sense?
Yep. Makes perfect sense. Thank you.
No problem, no problem. Does anyone else have any questions?
I see Dinesh Pappy typing. Let's give him 1 second.
Vanessa Pappy, boss man.
He asks, if you're training the headbutt, is there a way to also help the AI decide when to do the actual special, like the water wave, and in what situation to do an
Mm,
headbutt?
yeah, that is a great question. That ultimately comes down to what we were talking about before with probabilistically sampling directions, right? Because Yeah, you're right. Like when you're doing the headbutt, you have to hold one of the directions. And ultimately, what that'll cause is you to hold that direction. And to do sort of the elemental attack, it needs to be special and neutral direction. And so in the current framework where you basically deterministically select the actions and the dominant action is to move towards the right or the left, in that specific state, you won't actually execute the special. With that said, just want to reiterate, this is something that we are working on. Um, and yeah, we hope to get this implemented very soon.
Mhm, mhm. This can actually be another topic for a different session for GGG, because I think the cleaning of the data at the advanced config side will remove some idle data. So usually we don't want idle data, but in this case, we may want some idle.
You got it. Yep, you got it. Absolutely.
Yep.
We certainly do want idle data in this specific case.
All right. Sounds good to Pappy. He say thank you. Awesome, awesome. Let's see.
Cool.
Yep. Looks like we are clear of question for now.
Awesome. Well, no, this was fun, guys. I mean, I love talking about this stuff. And yeah, if anyone like kind of rewatches the video or and has questions afterwards, feel free to just drop it in the chat. And yeah, our team's always happy to help out.
All right. That sounds great. So the next exciting segment for today would be the quiz for all the previous GGG episode. So if you're
All
interested,
right.
let's thank you, Gabby, for his you know, detailed session on this
My
head
pleasure, guys.
and shoe concept. Thank you.